Hi everyone, welcome to today's session. My name is Elizabeth and we'll be continuing with the networking workshop we started in the last session. Um, we haven't gone too far, but I think we've set up most of the VPC environment. So this workshop is part of AWS Workshop Studio that is available publicly. It is free for you to access, but when you deploy services in the AWS environment, it may incur costs. So make sure to check whatever you are setting up if it is going to be beyond the free tier. I think this particular workshop, when we started, I'm just going to quickly look it up again. When we started, I think there's a cost estimate for what, not this one, yeah, this is the workshop. I just want to confirm the cost estimate again so that if you are joining from today, then you would be able to work on it if you want to. Okay, yes, so here it is. The cost of running this workshop in the US East 1 region, I think that is the Ohio region, is $7. And as I have said, different regions incur costs differently for some AWS services. So this $7 may not be the exact same amount in any other region you are using. If you want to be sure that this is the amount that you may incur, then maybe use US East 1 region. And yeah, so we can get back to where we were. We were in VPC fundamentals. So we had gone through creating the Amazon VPC. We deployed the subnets that we needed, two public subnets, two private subnets across two availability zones, and the network access control lists have been created. I'm going to open the console environment so that we can all work together. So I'm going to console.aws.amazon.com and I'm going to log in with my user. I hope I remember the correct. Oh no. Ein Moment. I think AWS just wants me to change this password because I'm quite sure the password I just used is correct. Just give me a moment, I'll change the password and be right back. Okay, sorry for the short break. I had to fix the account login and I'm back. We were looking at what we did last week. I said we had set up the VPC, the subnets, the network access control lists, and we can just check the VPC environments to see that we have everything still set up as we want it to be. Yes, we have this. And the route tables, yes, we set that up last week. Internet connectivity set up with NAT gateway and internet gateway. So here we have our NAT. This is our internet gateway at the edge of our VPC, and then we have the NAT gateway here in the public subnet. We have only one, and we clarified last week that you would normally want to have one NAT gateway in each availability zone for redundancy, so that even if one availability zone goes down, your private subnet will still be able to carry out the tasks it needs to do through the other NAT gateway, basically, yeah. But for cost reasons, one is okay because NAT gateway incur costs. So yes, I think that was where we stopped last session, and we'll be continuing now with the VPC endpoints. Just to confirm, we haven't set up the VPC endpoints. I'm just going to open that and check. Yes, so we have no endpoints right now, and then we'll be working on that from now. So VPC endpoints, there are technically, not technically, just specifically, there are just two types of VPC endpoints. And the way VPC endpoints are, they are like private connections from your environment to AWS services without you having to traverse the public cloud space. So essentially, normally requests traffic that would normally leave your AWS account just to be done in another AWS environment can be done privately more securely. Endpoints. Yeah. So you'll be able to connect without going through the internet. I mentioned there are two types of VPC endpoints: gateway endpoints and interface endpoints. The thing you need to know is that gateway endpoints can only be used for S3 and DynamoDB. Every other service that you may need to use VPC endpoints for would need interface endpoints. So just know, S3 I'm using gateway endpoints. DynamoDB I'm using gateway endpoints. And the way the AWS environment is actually in the console, you would see the options clearly in your drop down and it's easy for you to navigate. But if you're going to be creating this using infrastructure as code, then you would probably need to know which kind of endpoints you want to create ahead of time so that you won't run into errors or issues while creating it. And as usual, the documentation is there that is going to show you your options and all that. So I think it works out fine. Now we have gateway endpoints, interface endpoints. For us, we need to check which kind of endpoints do we need, and that depends on which services we are trying to create a connection, a private connection to, actually. So I will share this link here in the chat. This is what are VPC endpoints, so that you can look at it if you want. It's just a white paper. There are a lot of white papers on AWS services, but it's really detailed on just VPC endpoints. So I'll be sharing it, and I think I'll be sharing links as we go through our sessions going forward. This is where I'm going to put this here. Okay, so back to our architecture. So far we have everything already set up except this part in the right, where you see the gateway endpoint connecting to Amazon S3 and the interface endpoints connecting to AWS KMS, we have every other thing in our environment. The VPC availability zones, network access control list, the subnets, and security groups, and basically all the other blah 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 already sorted. Now, first thing I want you to know is that AWS KMS is key management service in AWS environment. It manages your encryption keys and whatever keys that you're using to basically encrypt different things. There are different kind of KMS keys, but your encryption keys, you can store it in AWS KMS. And we're not going to be doing a session on KMS today, but you can bring your own customer managed keys, your AWS managed keys. It's just a key stuff, keys, service keys, storage keys. And to connect with KMS using VPC endpoint, we are going to have to use an interface endpoint. Why? Because gateway endpoint only works with S3 and DynamoDB. If you are preparing for AWS exams or something, you definitely need to know that, because that kind of things they ask you. Like they'll ask you which is, but when you need to create something and then you say, oh, set up gateway endpoint, you need to know like this works for only particular services. All right, so gateway endpoints for Amazon S3, interface endpoint for KMS. And I want to say that for all the services you're going to be connecting with and all, you have to have their own different endpoints. You cannot just say like, oh, I'm creating one gateway endpoint and I'll use it for S3 and I'll use it for DynamoDB. I'll create one interface endpoint and I'll use it for KMS, for what they call this thing, SSM, for everything I want. No, it doesn't work that way. So like, you're gonna see it as we're going, but yeah, create an interface endpoint for KMS. I shared the link that has all that detail particular to creating an interface endpoint, but we're going to follow this visual one here and we're going to start. So we're already in endpoints in our VPC console and we're going to click on create endpoints. These are our endpoints in VPC console. If you are not here yet, you can easily just search VPC in your search bar and click it, and then you'll be in the VPC area where on the left navigation sidebar here you'll find endpoints under private link and lattice. All right, so we can get started with our endpoint creation. So create endpoint, and let me see what they named the endpoint. So we'll just use the same name right here. The endpoint is VPC A KMS endpoint. We're following the same naming convention that we are using. We'll start with the VPC identifier, and whatever we're creating. So VPC A KMS endpoint, that's the name. And we're connecting to AWS service. There are different kind of endpoints you can create, as you can see. Different kind of endpoints. There's also EC2 Instance Connect endpoint, which is a different kind of endpoint particular to connecting to EC2 instances. So yeah, but that's another topic. You can see endpoint services that use NLB, that's network load balancers, and gateway load balancers. But most times you're creating endpoints, you just need to focus on AWS services because that's mostly what you'll be using it for. And as your knowledge expands beyond this, you can try out the other ones as needed for your particular use case. So back to our tutorial, we enter our name tag, we select AWS services, and you have to pick the particular service that you're trying to create an endpoint for in all the list of services available here. So the next thing would be for us to select the KMS service, and yeah, we'll come back to the details that will enter in the VPC. But let's pick this. We have our AWS services selected, and as you can see, there are a lot of services, up to like 29 pages. You can start looking through all these. I will search for KMS. You can see there are two different ones. It was clear in our tutorial that we're instructed to select the one that matches exactly what we want, and that is just the KMS. So this is it. We're selecting it, and our VPC is going to be VPC A. Be careful to make sure you select the correct VPC. Okay. Now let's check the particular settings that we are going to be using. Enable DNS name, and we are using IPv4. I mean, that's the only option we have anyway. Yeah. Okay. That is it. The subnets that we're going to be using it with, we're choosing the two subnets. You remember we have two subnets, so we're going to be picking the two of them, and then still the same IPv4 address type. Let's do that. So two availability zones, and normally you can have as many subnets as you need for your project here, and you would select a particular subnet in each availability zone to work with. So here VPC-A, we are using the private subnet, I believe. Let's confirm that. Yes, we're using the private subnet, VPC-A private subnet in the first availability zone, and VPC-A private subnet also in the second availability zone. The reason why I guess it was the private subnet is because, I mean, we're trying to connect privately. I mean, that's the whole point. We're trying to do this whole thing. So why do you have a public subnet? Yeah, so private subnet. And we IPv4. Yeah, okay. And that's all. The security group. Let's select that. The reason why we are not turning on this designate IP address option is because we want it to use the IP address it allocates to it by itself. If I want to write particular IP address here that I want it to use for this endpoint in the first availability zone, in second availability zone, I would select the designate IP address for myself, and I'm going to write it here. And it has to, of course, be available in that subnet, like selecting a particular one. But no, we're not going to be designating IP addresses by ourselves, okay? And we have just IPv4 available, of course. The security group, we're using the default security group. I think that is what was instructed for us in this particular zone. This is the default security group in our VPC. And full access is what we are allowing here. Because if we try to use custom access, we are going to be like writing what do you call this thing? Policy to restrict what or who can access this particular endpoint. So mostly you would want to use full access so that you don't complicate things for yourself. Yeah, how will I explain this now? So this is a private endpoint in our VPC to connect to KMS, the AWS KMS service. And we might have different services in our private environment that wants to connect with KMS. We want to allow full access for everything inside our VPC to use this endpoint for KMS, okay? Now, if I'm trying to restrict it and say custom, that means I'm going to be restricting what services can use this particular endpoint to connect with AWS KMS, which usually you don't need that kind of level of restriction, actually. Because you just want a private connection to KMS. That's our only requirement right now. If you have different security requirements or different reasons to try and restrict this connection to KMS via the private endpoint, then you may find the custom policy useful. But like 95% of the time, you don't need that kind of like level of granular restriction. Okay, so full access, and that would be all. Let me check if there's any other tag that was added. No, there's no other tags. We're going to click create endpoint, and we're going to go back to our endpoint screen. So create endpoint. I mean, it's pretty straightforward to follow the workshop by yourself if you want. But the reason why doing it together is to discuss the reasons behind the choices and the options you actually have, the issues that you may run into, and best practices generally. Yeah, that's why we're doing this together. So we have our VPCA KMS endpoint. It's pending. As you can see, it's in a pending status. You're not able to use it right now. But that doesn't stop us from creating our next one. We're creating the gateway endpoint to Amazon S3. So I'm guessing we're going to be using the same naming pattern. It's going to be VPCA S3 endpoint. Let me confirm. I'm guessing it's because if I was using this naming convention, yep, that's what I would name it. VPCA S3 endpoint. And it's going to be, of course, also AWS services. We're going to search for S3 and we're going to use it. So AWS services, type selected, and let me just search for S3. Yeah, you can see the different S3 related ones also, but what we're looking for is just S3. So select S3 and you go. As you can see, there's gateway, there's interface. We're going for gateway endpoints. Keep it simple. Select the VPC in, that's VPCA, and we're using the route tables. Let me see if they also included all the route tables. Yeah, all the route tables. Because, like I said, you want to keep it really simple with your endpoints. You want everything in your environment to be able to use the endpoints. That's why we're selecting all the route tables. So everything in every route table will be able to find it. And we're allowing full access also with create endpoints. Now, what did you notice was different about creating this gateway endpoint and the interface endpoint? I would say, obviously, we didn't need to do anything around like security group or the particular part where we needed to select the subnet and assign IP addresses if we needed to and all that. Like that was not there in using a gateway endpoint. I don't know if you saw when we were showing earlier about interface and gateway endpoints, it was written somewhere there that, the interface endpoints would create a network interface for that connection. And network interface, I mean, at least when you look at the Elastic Network interface in AWS environment, it's like it's like a network card on your device that has its own IP address, all the connection stuff that you need to be able to reach that particular device and all. And that's what enables it to actually have connections to internet and all that. Like, of course, an interface would need all those things that you would put for any resource that has this network interface in AWS environment. So your EC2 instance, of course, it has a network interface that you need to put, maybe which security group, which IP address, which all of that. That's why there's this difference between interface endpoints and gateway endpoints, because the interface endpoints actually creates a network interface. But yes, so we can create this and move on with it. Okay, so 2 endpoints we have here, and they are available, instantly available for our gateway endpoints. Interface endpoints needed some creating time, and you can check them out here. So for the interface endpoint, you see we have subnet, security groups, and policy, blah blah blah. But for our gateway endpoint, it's just really short, just route table, policy, and tags. Yeah, cool, right? Okay, so let's move on. We have created our VPC endpoint. Let me read what they wrote here. We have now gone through the bread and butter of AWS networking and built a networking foundation of public and private subnets across 2 availability zones with internet access and private connectivity to AWS service endpoints. So if we have something in our servers that is trying to fetch a file from S3, it's just going to do it securely through the AWS environment without having to traverse the public internet. And it saves you costs. That's something you may not know. But every request that you make to S3 that's coming from external, like basically every data transfer that goes out of S3, out of AWS environment, is costing you money. Okay. So if what you are fetching is within AWS environment, you really want to use a gateway endpoint that will just transfer that data within AWS environments and not go out of AWS environment, because it's going to cost you money. So it's important to know your endpoints to reduce your data transfer costs. There are some things that you may, know more as you go deeper, and some architecture decisions that would help you in terms of your data transfer model that you have seen. This is how we use data. This is our data access pattern, and if we do things this way, if we move things around, if we use this service in conjunction with this other service, we're able to reduce the data transfer costs and all that. I mean, I'm just saying, yes, this is one of the options that you should know when it comes to reducing data transfer costs. In the next session, we will launch an EC2 instance into both a public subnet and a private subnet to verify the connectivity. So let's go. Next. This is not our first time launching an EC2 instance in AWS environment. We've done it via the console. We've even done it via our code. Yeah, we used CDK the other day to launch some EC2 instances. Oh, I think it was one EC2 instance. And then we had the Tuscany group also. But we have a mission here. We're also going to be testing connectivity. We want to launch it. We want to make sure it's working fine. And we're to be going further in terms of networking. Yes, I hope you can see everything on my screen. Okay. So this is where our EC2 instance is going to be in the public subnet, and this is where our EC2 instance is going to be in the private subnet. It's easy to deploy resources in AWS environment when you have your architecture diagram to look at. So you know where things are at a glance. Like, okay, the public subnet I want has this amount of IP addresses available, and it is in availability zone B, and yeah, it just makes things easier. We're going to get started. So the first section, we are creating an EC2 instance in our public subnet in AZ2, and the next one will be in AZ1, but let's start. Public subnet in AZ2. Let's go to EC2. Virtual servers in the cloud. EC2, we're going to instances, and we're going to launch instance. Now, what's going to be the name of our instance? Let's see. The name is VPCA public AZ2 server. We can copy that, and we're going to get started. So for us to follow the exact specifications that is required, I will just split my screen in two so that we can have the instructions on one side and we have our console on the other side. Okay, so this, I'm going to bring it out in a moment, and this is going to be here like this. Just need to move this around a little. Oh no. Yeah, I think we're good now. So, yes, our name of the name of our instance is VPC a public AZ2 server, and we are selecting Amazon Linux, the 2023 AMI. That's what is selected here already, and the instance type has to be T2 micro. Okay, so I'm going to come here. That's already selected also. I think we're just using all the default stuff. T2 micro with key pair. So the key pair is a, what I say, I mean, it's a key pair, like public key, private key pair that you can use to SSH to your instance. The SSH, when I say SSH, yeah, we use SSH like a verb. It's not really, it's not actually a verb, but you use it to create the SSH connection to your instance so that from your local server, like your system in your house or in your office, you are able to get into your AWS server and do stuff there. So you can try to create a new key pair and save it locally, or we can proceed without a key pair. We're doing that. The reason why it is not recommended to proceed without a key pair is because when you create an instance without a key pair, you cannot change that. Like, you cannot just suddenly now say, okay, now I want to put a key pair on it. It's so much more complicated than that. So it's usually recommended create the key pair, save it, even if you don't plan to use it at all. Just save it, and then you can use your instance without bothering with the key pair. But just saying. Under the network settings, we currently have default stuff, I believe. Yeah, nothing here. We want to create a security group. So we're going to be editing this to be sure we have what we want. As you can see, this is the default VPC. We don't want that. We want VPC A. And in the subnet, we want public subnet AZ2. So this is it here, public AZ2, VPC A public subnet AZ2, and we are going to auto assign the public IP. Yeah, there's a reason. Normally you may want to disable auto assign public IP so that your instance does not have any public IP address, only the private IP address, and then you can now make it public in the way you want it to. But when you select auto assign public IP, when you enable it, as you create your instance, the instance is assigned a public IP address that if you have that public IP address, you're able to load the instance or connect to it, whichever way. Like if I put it in my browser, I'll be able to get a response from it. And usually you want to not put a public IP address that is accessible from anywhere, like from people. But we're doing that. So we're going to enable this, and the settings with our security group. We're creating a new security group. Okay, I know that we didn't before. We're creating a new security group, and it's going to be called VPCA security group. What a genius name. The description is open up ports for ICMP. This ICMP, like, I know what it does, but honestly I don't know the full. Let me look it up. I don't know the full internet control message port. Yeah, but it's used to, like, we use it to ping, to try and access to. It's just for diagnosis mostly in network communication. So ICMP, we are using this to open up ports for ICMP, and we're saying, okay, this is SSH. You know, I was talking about SSH just now. SSH is usually port 22, and I don't think we are trying to set up SSH. Let me see, what do we have here? Because if you don't have your key pair, what are you going to be SSHing anyway? But yeah. Oh, so we are opening up everything. So we are using only IPv4 in our environment, and we are opening up all ICMP. That's IPv4, and source type is to anywhere. That's it. I don't need to type 0.000 like they say, because anywhere is 0.00. And I think that is all. Yeah, that's all. Interesting stuff. Can save this now. Okay, we also need to change advanced network configuration. So under primary IP here, we're assigning a primary IP address for it. 10.0.2.100. Normally you don't need to do this, but I think it's for the point of the tutorial that we're following, so that we have the exact IP address that we want. But normally we don't need to do it. This is the primary private. You don't need to do this normally. It's kind of like the same one of whether you want to auto assign the IP or you want to, yeah, that kind of stuff. So we can continue. Let me see at the bottom of the section. We also need to make a change in the instance profile. Yes. So the instance profile is like a role, we've talked about IAM permissions, roles, users earlier in a different session, but it's essentially an IAM role that you assign to your instance that allows the instance to be able to access other services or fetch things, like carry out or connect to services in your AWS environment. If you don't have your instance profile correctly, you may get errors when your server is running, trying to do some things. Like, okay, you have this particular instance that you are running your web server on, and you want to connect to your database, whereas the instance profile does not have access to connect to the database. You're going to run into errors, access denied errors. It's just basically permissions for your server to do things, connect to things, fetch things in your AWS environment. And outside your AWS environment too. Like, okay, I want this thing to be able to assume a role, to be able to do something on another account, basically stuff like that. So expand advanced details. Where is advanced details? Here. This is it. And we are going to edit our IAM instance profile. So this is networking workshop instance profile. When we ran our prerequisites section in the beginning, that we deployed like a template of IAC, infrastructure as code, to provision things in the AWS environment, we were able to create this. I actually would like us to look at what this instance profile looks like in the IAM environment, and we'll come back here. So networking workshop instance profile, I'm going to open IAM in a new tab, and we're going to look at it before we come back here. So this is the IAM dashboard. We have 13 roles in our account. This is networking workshop. Which one is it again? Networking workshop instance profile. Let me look for it. It should be this one. Yeah, this one. So you can see the role itself is networking workshop EC2 role. The instance profile is networking workshop instance profile. So the instance profile has, this is the role. Here you can see there are 2 permissions attached to this role. You have S3 full access. That means we're going to be doing something. This server would need to connect to S3, and SSM managed instance core. This one is required for all your EC2 instance profiles. If you want to be able to use the AWS session manager, this Amazon SSM service to manage your instance. So you want to be able to log into the instance in your AWS environment using session manager without having to SSH like from outside AWS and all that. Or you want to be able to go to SSM environment and see the instance, perform some things on the instance, manage it together with other instances. Like essentially you want to make sure you have this one on your EC2 instance. And if you are trying to connect to your EC2 instance with SSM and it's not working, or you see that it tells you, oh, your instance has issues registering on SSM or something, it's possibly a role issue. Like when you check here, you see like, oh, you haven't attached this permission to your role. And then the trust relationship here, as you can see, the trusted entity here is EC2, Amazon EC2. So we have the same way you write your policies. The effect is to allow this principal, which happens to be a service identified as ec2.amazonaws.com, to assume this role, STS assume role. So yeah, that's what the role looks like behind the instance profile. Okay. Now we can get back to where we were. I just wanted you to see what it looks like. It's nothing really special. It's just granting permissions to your instance. So we select that file and we would launch the instance. We're not making any other changes. Over time, as you work on more specialized projects with particular tasks or requirements, you may need to change a lot of other nitty-gritty details in your instance setup. But for now, this works perfectly fine for us, and we would be launching this instance. So the instance should be in a pending state. Oh wow, it's running. That's really fast. Okay, yeah, it's running. The status is initializing, like the status check is checking to see if it is in a healthy state, if it passes the health checks that it's expected to pass. But that's all we need actually to move on. So we have one instance here, and we need to create the other instance in the private subnet. Okay. We're going to launch our instance. The name is going to be they are trying to create it from a template, but I was thinking we can actually create it from scratch by ourselves. What do you think? We can just go and create it. So I'm going to use the template option to we select the instance we already created, and we should already have it passing the 2 health checks. Okay, it's not yet passed, but it's running. So I'm going to use this to launch instance. No, launch more like this. That's what I'm going to do. They are different. If I came here and select launch instance from template. It's going to ask me to pick from the templates that we already have, which we don't have any templates. But because I select this particular instance, I can check the actions on this particular instance, select the image and templates, and launch more like this particular instance without having to create a template from it first. All right, so we are using this, we're changing the name to private. And since we are going to be launching it in AZ1, we're changing that also. So the name is VPCA private AZ1 server. And we're also going to be proceeding without a key pair, just like we did in the other one. Proceed without a key pair. And the subnet is going to be the private subnet in, where is it? The private subnet in AZ1. Don't make a mistake. I know that we have more than one subnet here. Private subnet AZ1. And we are going to disable the auto-assign public IP. Remember what I mentioned about auto-assigning public IP? You don't want people to reach your instance. Make sure you disable auto-assign public IP. This is our private instance. We're disabling it. We don't want it to have any public IP address. And advanced network configuration, like the other one, we're going to put the IP address that we want here as the primary one, 10.0.1.1. You know, it has to be in the range of IP addresses that are available in your subnet. So this is not just a random number. If we go and check our subnet, you'll see that it fits into our CIDR block. And we're going to launch the instance. Okay, let's see what we have. You should have 2 instances. Yes, 2 of them are here. The first one we have is already all done with a status check. The second one is running, but the status checks have not yet completed. And we're done. Public subnet, private subnet. I want us to check the points that we discussed about the IP addresses. So this is the one that we created in the private AZ1 just now. And as you can see, it has the private IPv4 address that we typed there as our primary IP address. It gave it what we wrote. And it has no public IP addresses. But in our public AZ2 server, it has a private IP address, exactly how we wrote it. But you can see it also has a public IP address. The public server, because we enabled the auto-assign public IP, it has a public IP address. And the consequence means it also has a public DNS. So you can check it with the IP address, you can check it with this URL. And let's try it, you'll see here. This one, open. It's loading. Let me open the public DNS. Depends on what we have allowed in our network access control list, in our security groups, in all the other different layers of security, yes. But if peradventure you have it open at any point to allow traffic into that environment, and we get this public IP address, this public hostname, we are going to get right into your server. I mean, at least we're going to be able to send the request to it to try and overwhelm it with so many connections and all. So be careful about enabling public IP addresses. And next, so we can't connect to it yet. We can see it's still loading and loading and loading and loading. Yeah. So meant to test connectivity. Let me see how long this particular one is. We'll complete this test connectivity and then we'll wrap it up for today so that we can finish these VPC fundamentals and clean up everything. I don't want us to leave the EC2 instances running. That's why. So let's do this. Okay. Here we can't reach it, as we can see for now. So we're going to go to instances. That's where we are. And we're going to select the public server. In the details, we've already done this. We've checked the public IPv4 address and we opened it didn't work. But if we try pinging it, let's check. To ping the instance, you open your CLI and then we ping it. Okay, so let's ping this one. Okay, where's my terminal? My terminal is not here. We just open terminal. It's really tiny. Okay, let's work together. So we're going to be pinging this. Ping. Put the IP address and here. So we are able to reach it because we opened access on ICMP ports, but we're not able to access it on, say, port 80, port, let's see. This works with our ICMP ports access that we opened up. Now, remember I said no matter what you're doing, if you have public IP addresses open, whatever, make sure your firewalls are very secure. Your security group, your firewall, like whatever you are that you're allowing in, is really restricted. And yeah, that should solve it. So we have access between our public EC2 instance and the internet because we have our responses here, as you can see, and there was no packets dropped issues. Now we need to test our private instance connectivity. So ideally we should not be able to just access our instance like that from the internet because it doesn't have a public IP address. Okay, but the private IP address, we should be able to connect to it from inside our AWS environment at least. So in the instance section, I'm going to put this one, minimize this. Yeah, we're going to select our private server and we're going to connect to it. This is what I was saying, that we have different ways of connecting to our instance. Remember, we have EC2 instance connect, and then we had that, we can use EC2 instance connect endpoint. Here you can see this option. We're not doing all of this, but I'm just showing you like what we were seeing in the endpoint creation. There was a type of endpoint called EC2 instance connect endpoint. It has its own use. But here we are using session manager because we have added SSM managed instance core permission to our EC2 instance, and it's able to register itself with SSM and all that. We're able to use this. So we are not using SSH or anything. We're connecting with our session manager and we should be inside our EC2 instance. Yes, we are. So we are going to ping. Yep. This is remember, this is our EC2 instance private IP address. But I want to show you this one that they wrote here is actually the address of your your public instance. Do you see it? These two IP addresses. They didn't write it here, but the instruction is actually telling you to ping your other instance and then to ping example.com, like just two different stuff we want to check. So we are logged into our private instance right now, and we're going to try to ping this IP address that belongs to our public EC2 instance. We might not be able to connect with our instance from our local environment, like from my terminal. If I try to ping the private instance, it would not work for me. But within the AWS environment, we are able to connect with each other like this because our network rules allow it. So the next thing they said we should ping is to try pinging example.com. As you can see, we also have the connection. It's able to ping outside and it's able to also ping inside the AWS environment. This works because in the AWS environment, our rules in the AWS environment allow this network traffic from our private instance to our public instance. It allows them to connect locally. And the one that is pinging example.com works because we have the rules that allow our private instance to also use the NAT gateway to connect with outside. In that sense, it's able to have like traffic going out through the NAT gateway and return to itself, but it's not open publicly for the entire world to try and connect to the private instance. No, it's shielded, but when it needs to connect to the outside world, it uses the NAT gateway through our public subnet and finds what it wants to do. That's why we're getting responses even when we ping example.com, which is outside our AWS environment. I just thought to explain that. Now we have these responses, and we have been able to see what I was trying to say. Like the connection follows these arrows. Okay, so starting from here, this is our private instance in our private subnet, and our first ping, which is to the EC2 instance, it checks the route table here, and the route table allows it to forward every connection to the public subnets, and it goes to the EC2 instance because the route table found that this IP address is in the local environment. So everything that is in the local environment should be resolved locally. Everything that is not in the local environment should be forwarded to the internet gateway. That's what this route table says. And that's what happened. So the first one went through this route and came to our EC2 instance. The second ping went through this route and found its way to the internet gateway where we got our response from. Okay, so back to this gateway and interface endpoint approaches. So we're going to check this. I'm not going to be dig is one of the tools that you use, or the commands that you use to diagnose like network connections. You can look it up. kms.us east 1 .amazon aws.com. So I have a reservation around this. I'm going to confirm something. In our environment here, I'm going back. Let me just open a new page for VPC. Open this new page. So VPC, let's check our endpoints. KMS endpoint. Let me of this so we have more space. Okay. So our KMS endpoint is EU Central 1. Our region is Europe and it's EU Central 1. Here you see that there US East 1. It's different. It's different. I just wanted to, because I saw this, I'm like, I'm not working in the US East 1 environment. I don't expect this to be what I'll be using. So I'm going to be using KMS, EU Central, whatever zone you are using, check it and make sure you're using the corresponding one. So I'm going to go back here and I'm going to correct this. So kms.eucentral1.amazonaws.com. This is my response. Okay. So this response points to 2 local IP addresses within our VPC-A private subnet CIDR blocks. Here you see, here there's 2 ones, as you can see. I wonder if you understand what we're looking at right now. But every other thing is just peripheral information. The main thing is this answer section that we see here. These are the A records. So in your DNS records, for instance, you're able to have different kind of records in your DNS. But when you see this is saying that this host name, this URL entry resolves to this and this IP addresses. And these IP addresses are inside our subnets. I don't know if you have watched any of the previous sessions where we discussed CIDR blocks, CIDR ranges, how it's calculated and how you allocate it in your subnets and all that. Remember when we're creating our endpoint, we had to specify, okay, which subnets this would be in interface endpoints. Now we're checking KMS right now, and KMS was an interface endpoint. So we needed to specify which subnet is going to be in. And we also had the choice of assigning particular IP address if we wanted to say this IP address for this. We could write the IP address as we wanted. So the reason why we are having this kind of situation is because we did not put a particular IP address. So this is what it allocated to it. But the bottom line is that it is within our CIDR block. It's within the range of our CIDR block. Yes. Yeah. Okay, so we can continue. So because the VPC DNS is returning the IP addresses of the Elastic Network interfaces that is in the private subnets, it would use this instead of public IP address for KMS. So the traffic to KMS, we said it's going to be routed within your private environment. It's not going to go through the public. Because as we're checking for this KMS URL within our server, in our environment, it's showing us IP addresses that is in our environment. So if we're trying to fetch this, it's going to be resolving it as if it was a local IP address in our environment, which it actually is, yeah. So these are reasons why you would want to consider endpoints whenever, I already mentioned data transfer charges, whatever, but yeah. So this is how it works. Follow the arrows with me. This is our private subnet where we have our private instance. And as we run this command now to dig KMS URL to see what it is, it comes through here to the Elastic Network interface. And this Elastic Network interface that is found is going to be the one for the interface endpoint that is for AWS KMS. So it creates a network interface in our subnets that resolves to this one behind the scenes. Basically, it didn't go through the internet gateway publicly outside like you would expect it to, because so that's how it works. We're going to terminate this session now. We're not using it, and we're back to our environment. So now, how does the gateway endpoint work? We've seen how interface endpoints work, and I expect you should be able to explain why it works locally in your AWS environment with what we just checked and how it routes it. Now, for the gateway endpoints, how does that work? When we check our root tables, where is it? Oh, wait, I go back up. Should be somewhere. Yeah, okay, stop. So we check the root table in our private root table. And let me just make it bigger. We're going to go to the routes tab and we see everything here. Aha! So we see that there is an entry that has a VPC endpoint as a target. That's how gateway endpoints work. So this destination, how do I explain this? There are different kinds of destination in AWS environment. It can be a CIDR block like this one that has the IP address and then the CIDR mask that says how many IP addresses there. It can be to say, depending on where you are talking destination, for instance. It can be, if you're in a security group, it can be to another security group. It can be to a particular service or something. And there's now this one that is a prefix list of addresses in the AWS environment. I mean, PL, I think it means prefix list. If I click this, you'll see something now. It's just a prefix list here. I know, let me go back. I select this prefix list, and here you will see the details of this. These are the entries inside this prefix list. 52.219, 52.219. This is a list of IP addresses, like IP address blocks that belong to AWS. I don't need to know where this resolves to, but you can see this is labeled as S3 in EU Central 1. In your VPC environment, in this list, if you come here and check manage prefix list, you will see a list of different prefix lists. You see a list of different ones that belong to different services. Can you see this? There's prefix list for CloudFront, there's prefix list for DynamoDB, prefix list for health checks. There's some prefix lists that are already like predefined addresses belong to AWS. So that is what is entered here. So the destination is prefix list belonging to S3, and whenever the destination is in this prefix list, it should set the target as our VPC endpoint. Our VPC endpoint here is, this is the S3 endpoint, as you can see. No, I have more than one selected. I'm going to close this first. Yeah, this is it. 06EED1. So that prefix list is pointing to our S3 endpoint. So this is exactly what happens here. Because the S3 prefix list is more specific than the default routes to internet, it would pick it over the internet traffic. So it's a list of IP addresses that it's pointing to our endpoint, and anytime whatever you're trying to go like fetch matches that. Once it resolves to that IP address, which is the S3 endpoints, it's going to go there to the S3 endpoint. So that's how it works. So this one, as you can see here, this is our EC2 instance in our private subnet. It checks the routes table and goes to the gateway endpoints. The previous one, remember, it finds it locally, the interface, network interface in our environment, and that network interface resolves to our interface endpoint. But with the gateway endpoint, it uses the prefix list, which directs it in the route table to go to the gateway endpoint that we have, and that's how it finds S3. So that's how it works, and I'm happy that we've been able to cover all of this. I think it was a really productive evening. I think that we know so much more than when we started, and I also was reminded of a lot of things as we got to discuss them. Gateway endpoint, interface endpoints, they allow secure connections in your environment, but they work differently. The way they are resolved are quite different, yes, because there are different services and different requirements. But point is, they keep the traffic within your AWS environment and it doesn't get outside it. Thank you for joining today. I look forward to seeing you again next week. Don't forget to clean up everything that you deployed, especially because we deployed some EC2 instances. You don't want that running till next week. So yes, don't forget to clean it up. You can easily just follow the steps. Delete the EC2 instances, delete the VPC endpoints, and then you delete the entire VPC. Lastly, you go to CloudFormation and you delete the stack that we deployed. That one is going to pull down everything else that we set, like the IAM roles and all the other prerequisites that we deployed. Just 4 steps basically. Delete the instances, delete the VPC endpoints, delete the entire VPC. It will pull down all the subnets, everything else, and delete the CloudFormation stack. Thank you and have a nice evening. Bye bye.